Today we'll look at how to create a compression-only support on the outer diameter face of a bottle. We'll begin by creating our simulation files. We'll also create a linear static solution, and we'll take the defaults. We'll begin in the idealize part, where we'll create an associative copy of the geometry so that we can prepare it for brick meshing. Here we'll split the bottle in half. Since we have a hole in the bottom, we're ready to go to the FEM where we can create our brick mesh. But before we do that, let's create our glue coincident mesh mating condition so the two halves of the bottle will be connected. So here we'll create a C-hexa 8 mesh with a global element size of 1/10 of an inch. Since the CAD geometry has a material assigned to it, we by default are inheriting that material to our physical properties for our solid mesh. Next we'll create a global constraint in our global constraint container, where we'll fix the edges of the bottle in the radial and theta directions. Next we'll create a load in our global load container to define an initial stress-free temperature. And for our first subcase, we'll make this our hot subcase, where we'll create a uniform temperature of 90 degrees on our model. Next we'll create a new subcase, which will be our cold subcase. And in here we'll create a uniform temperature on the model of 50 degrees. Alright, so let's go ahead and solve. Here I'll pause the video, but you can see it only takes about 6 seconds to run. And then we can view our results for our hot and cold subcases. So here for our hot subcase, you can see the bottle is growing, and for our cold one you can see it's shrinking. And if we take a look at the stresses, because of the constraints that we've defined, you can see the stresses are effectively 0 for each of the subcases, hot and cold. Alright, next we'll create our compression-only support. We'll begin in the idealize part, where we'll extract the faces where we want to apply our compression-only support. Alright, now that we have those faces, we'll go to the FEM, where we can create a mesh on those faces. So here, to make that a little bit easier to see, I'll turn off the solid mesh and the solid geometry of the bottle. Then I'm going to create a shell mesh with the same order and the same element size as my brick mesh. Now, since we don't have a mid-surface to inherit thickness or materials from, I'll specify a material and a default thickness. Both of these values are irrelevant. However, they need to be defined so that the model will solve. Alright, next we'll go to the sim where we'll define a fixed constraint on our compression only support faces, and that constraint is going to go into our global constraint container. So here I'm selecting the faces of my compression only support. Next we'll create surface to surface contact between our compression only faces and the solid faces of our bottle. Alright, once we've selected our source faces for our contact, our target faces are going to be on our bottle. So let's turn on our solid geometry of the bottle and the solid mesh. And we'll select our target faces. Then we can specify a min search distance. And we also need to specify contact parameters. Because we had to specify a thickness that we don't want to include in our compression only support, we'll turn off include shell thicknesses. So that way we won't have an offset with an initial compression on our bottle. Alright, next taking a look at the side of the region. Since we extracted faces from the solid of the bottle, the shell mesh is going to have the surface direction incorrect. We need to select the bottom surface for our shell mesh. And we could have done that during the region selection, but here you can see that the markers were in the same direction, so we needed to reverse the shell mesh region. Alright, now we're ready to solve, and here we can monitor the progress of our solution looking at contact convergence. You can see for our first subcase that one's converged. Now we're on to our second subcase, and here I've also paused the video. You can see the total time to solve is just a little over 30 seconds. So let's go ahead and take a look at our results now. First for our hot subcase, and you can see that compression only support squeezing the OD of the bottle as it's trying to grow thermally due to our hot subcase. Going on to our cold subcase, you can see that there is no contact now between the bottle and the compression only support. To see that a little bit better, let's take a look at our stresses. Here you can see with our cold subcase we have no stress in the bottle, and in our hot subcase we can see we do have stresses in the bottle due to our compression only support.